0 into y and 2 into z. So just plug it into x, y, and z, but it has to make sense into all three equations. So you have to plug it into all three. But use your answer choices to help you. Don't sit here and solve this out. This is probably one of the most time-consuming questions where you can kind of cheat and use the answer choices. Does that make sense? Number 9 says, given the augmented matrix below, write the system of equations. So this is just writing the system of equations. So we have 9x plus 0 is y, so we don't write it. So plus 11z is equal to -3. Then you'd write the next equation. -6x plus 2y plus 5z is equal to 2, and so on. All right, let's look at F on the next page. So here we're multiplying C times B. So I'm going to rewrite them in the order that we're multiplying. So C is 0, -5, 2, 3, -4, 7. And B is 2, 1, 2, 5, -6, 5. So when we multiply, the order matters. In the first matrix, we move in rows. The second one, we move in columns. So starting with our first row, first column. Oh, let's make sure that their sizes we can actually multiply. So the first one is a 3 by 2, and the second one is a 2 by 3. Can we multiply these two together? Yeah. The insides are the same, so we can multiply, and our answer is going to be a 3 by 3. So I'll write that down here. So we know our answer is going to be a 3 by 3. So in our first row, first column spot, we start with the first row, first column. So we have 0 times 2 would be 0. And the second number times the second number would be -5 times 5, which would be -25. 0 minus 25 is -25. Now we can do the first row, second column. 0 times 1 is 0. -5 times -6 is 30. So 0 plus 30 would just be 30. Then the first row, third column. 0 times 2 is 0. -5 times 5 would be -25. 0 minus 25 is -25. Now the second row, first column. 2 times 2 is 4. 3 times 5 would be 15. And 4 plus 15 is 19. On the test, use your answer choices to help you. If you get this far and notice that there's only one answer choice that has these 4 answers, you could just stop and pick that answer choice. So you don't have to work out every single problem completely. Use your answer choices to help you. Use process of elimination. We'll keep going to solve though. So now let's do second row, second column. So 2 times 1 would be 2, and 3 times -6 is -18. 2 minus 18 would be -16. And then second row, third column. 2 times 2 is 4. And 3 times 5 is 15, and 4 plus 15 is 19. Now, third row, first column, -4 times 2 would be -8, and 7 times 5 is 35. -8 plus 35 would be 27. Third row, second column, first times the first would be -4 times 1 is -4, plus second times the second. 7 times -6 is -42. -4 minus 42 would be -46. And then lastly, third row, third column. So first times the first would be -8. 7 times 5 is 35. Negative 8 plus 35 is 27. So that would be our answer. All right, next page. For 12, let's find the inverse. So to find the inverse, we switch the majors. So we switch the positions there. So it'd be negative 3 up top and 2 on the bottom. And then we negate the minors. So negative 5. And since it's a negative 9, we change it to positive 9. And then we multiply by 1 over the determinant, which is majors minus minors. So 2 times negative 3 would be negative 6. Minus, the minors would be negative 9 times 5, which would be negative 45. So this turns into a plus. Negative 6 plus 45 would be 39. So here we're multiplying 1 over 39. We distribute that to everything. So we get negative 3 over 39, negative 5 over 39, 9 over 39, and 2 over 39. And then just simplify. So 3 goes into 39 13 times, so this would be negative 1 over 13. 5 does not go into 39, so it stays negative 5 over 39. 3 goes into 9 and 39, so it'd be 3 over 13 and 2 over 39. So that would be our answer. Yes. So we do 1 over the determinant, which is 1 over majors minus minors. So we multiplied 2 times negative 3 and got negative 6 minus negative 9 times 5, which was negative 45. Any questions here? All right, just for fun, I'm going to make this a 12b. Let's say 12b asks to find the determinant. So find the determinant of the one we just did. So when we find the determinant of a 2 by 2, it's just majors minus minors. Remember, majors start from the top, minors start from the bottom. So majors, 2 times negative 3 would be negative 6. We kind of just did this. Minus minors, which would be negative 9 times 5, so negative 45. Minus negative turns into a plus, so our determinant would be 39. So make sure you know how to find the determinant of a 2 by 2. All right, 13, we're going to find the determinant of a 3 by 3. Does anybody remember what we do first to find the determinant of a 3 by 3? Awesome. Rewrite the first 2 rows on the outside. So we have 0, 2, negative 4, negative 2, 8, 0. So then we do majors minus minors. Majors start from the top, and then minors start from the bottom. So 0 times 8 times 7 would be 0. Negative 2 times 7 times negative 4. Negative 2 times negative 4 would be 8. And 8 times 7 is 56. And 1 times 2 times 0 is just 0. So we get 56 for our majors. Minus, let's find the minors. Negative 4 times 8 times 1 would be negative 32. 0 times 7 times 0 is 0. And 7 times 2 times negative 2 would be negative 28. So negative 32 minus 28 would be 60, negative 60. We have to add these when we subtract a negative. So 56 plus 60 would be 116. All right. Next page, let's do, I'm actually going to come back to this one, but I want to do B if we have time. This is more of the newer stuff though, so I kind of want to make sure we have time to get to the old stuff. So I would highlight B, make sure you know how to do this one. If we have time, I'll come back to it. All right, so next let's look at 23. It says, given the sequence, write the rule to find the nth term and find the indicated term. So first let's figure out if this is arithmetic or geometric. We want to know if we're adding to get from one number to the next or multiplying. So what do we think? Are we adding or multiplying to get from one number to the next? Adding what? 7. Perfect. So that would make this an arithmetic sequence. And our arithmetic sequence formula is a sub n is equal to a1 plus n minus 1 times d. Again, formulas will be given to you. Just make sure you know what to do with them. So when we write the rule, we need to plug in our common difference and the first term. So a sub 1 and d. What's our common difference? 7. And what's our first term? Awesome, negative 11. So we have a sub n is equal to negative 11 plus n minus 1 times 7. Now remember, it's multiple choice, so it could be written like this. It could also be simplified. So we could distribute the 7. So we have negative 11 plus 7n minus 7. And then combine our like terms, so 7n minus 18. So these are both right answers. It just depends on how it looks on the tests for your answer choices. All right, next, we want to find a sub 19, so the 19th term. So we're going to plug that in. You can plug it into either formula. You'll get the same thing. So I'm going to plug it into the simplified one. So you have 7 times 19 minus 18. So when you put this in the calculator, you should get 115. Any questions here? All right, next page, let's do 28. So given the sequence, write the rule to find the nth term, find the indicated term. No decimals. So first we want to see, is this a geometric sequence or arithmetic? Are we adding or multiplying to get from one number to the next? Multiplying what? Awesome, we're multiplying just 2? If it goes from being negative to positive, negative, positive, what are we multiplying? Negative 2. So we're multiplying negative 2. So our rule for our geometric, this would be geometric, would be a sub n is equal to a1 times r to the power of n minus 1. So we have to plug in the first term and our common ratio. So a sub n is equal to, what's our first term here? Negative 2 over 3, bless you, times negative 2 to the power of n minus 1. Here we can't do anything to simplify. A lot of people on the last test multiplied the two numbers together. Remember, you cannot do that because negative 2 has an exponent. So you have to do the exponent first. So let's plug in 15. So we have negative 2 over 3 times negative 2 to the power of 15 minus 1. So negative 2 over 3 times negative 2 to the 14th power. When you put this in your calculator, don't forget to put it in parentheses. Anytime you have a negative number to an exponent, put it in parentheses. If you don't put it in parentheses, it'll always leave it negative. So negative 2 to the 14th power is positive 16,384 times negative 2 over 3. We can make this 16,000 over 1. And then just multiply the tops together and multiply the bottoms together. So times negative 2 on top would give us negative 32,768 over 3. All right, there'll be a Pascal's triangle question. I don't know if we're giving you the Pascal's triangle, so make sure you know how to come up with it. So Pascal's triangle, we have a little triangle of ones. The next row would be 1, 2, 1. Next row would be 1, 3, 3, 1. And we have 1, 4, 6, 4, 1. Remember, you just add the two numbers in the row above it, and it always starts and ends with the 1. Here we have the 4th power, so we're looking at the row that starts with a 4, or the second number is a 4. So we're using the coefficients 1, 4, 6, 4, 1. Then in the next row, we have 3x. Be careful here. It's 3x to the 4th power. The 3 is also being raised to the 4th power. This is one of the most common mistakes that people made on the last test. Then we have 3x to the 3rd power, 3x to the 2nd power, 3x to the 1st power, and 3x to the power 0. And then our second number is 2, or negative 2. So we have negative 2 to the power of 0, negative 2 to the 1st power, negative 2 to the 2nd power, negative 2 to the 3rd power, negative 2 to the 4th power. Now we're going to multiply our columns together. So when we have 3x to the 4th power, it is 3 to the 4th power and x to the 4th power. So 3 to the 4th power would be 81 x to the 4th power. So again, this was probably the most common mistake that people made on the Pascal's triangle question on the test. They forgot to distribute to the 3 and the x. Negative 2 to the power of 0 just goes away. Then here we need to distribute the 3 again. So 3 to the 3rd power would be 27x to the 3rd power. So now I have 27 times 4 times negative 2. So this would be negative 216x to the 3rd power. Same thing with the next one. I need to distribute the 2 to the 3 and the x, so it would be 9x to the 2nd power. So we have to multiply 6 times 9 times here, 2 to the 2nd power would be 4. So 6 times 9 times 4 would be positive 216x to the 2nd power. Next one, we have negative 2 to the 3rd power, which would be negative 8 times 3 times 4. Be negative 96x. And then 3 to the power of 0 just goes away. Negative 2 to the 4th power would be positive 16 times 1 would just be 16. So this would be your answer. This is another one of those questions where when it's multiple choice, if you're confident in your answer on like the first term, you could kind of use process of elimination and stop. You don't have to work your whole way through, find each term. If you find like the first 3, you could probably pick your answer choice. Just make sure that you didn't make a mistake. If you've got a minus sign in the middle, your signs are going to alternate. All right, next we are expanding and condensing logs. So any coefficient that we have is going to go up as an exponent. Here we're missing a y on this middle log. It should be log base 4 of y. And then 5 is going to go up. So we have log base 4 of x. It'll either be written as x to the 1/2 power, or what's a different way that we can write the 1/2 power? Awesome, square root x plus log base 4 of y to the 8th power minus log base 4 of z to the 5th power. Now when we add, what do we do to condense our logs? What goes with addition? Multiplication. And what goes with subtraction? Division. So we're going to have log base 4. We multiply the two things being added together, so square root x times 8y, over, we divide what's being subtracted, so z to the 5th power. Right, next one, we are solving our log equations. So when x is in the exponent, you always want to get whatever has that x all by itself. So we need to move everything else to the other side. So we're going to add 3. So 8e to the power of negative 2x minus 9 is equal to 10. Then again, we want to get that e all by itself, so I have to divide by 8 because 8 is being multiplied to e. So move it to the other side, we divide. So e to the power of negative 2x minus 9 is equal to 10 divided by 8, which is 1.25. Now we use logs to get rid of the exponent. So here I'd make it log with whatever base is the base of that exponent. So log base e, which would be ln. So we take the ln of both sides. So it cancels out with the e. So negative 2x minus 9 is equal to the ln of 1.5. So we're going to put that in our calculator, which gives us 0.22314. It keeps going, but we're just going to leave it in the calculator and do the last couple steps. So then we're going to add 9 to it. So we get negative 2x is equal to 9.22314. And then divide by negative 2. So x is equal to negative 4.6. I think it says 3 decimal places. Yeah. 1, 2. Yes. I'll go back in a second. But just as a reminder, if I had, let's say, 5 to the power of x is equal to 7, how would we solve for x here? Log. We use logs. What would the base of our log have to be? It's got to be the same base that has the exponent. So log base 5. So it'll cancel out here. So we have x is equal to log base 5 of 7. How would we put this in the calculator? So it'd be log base 7 divided by log base 5. So when you put that in the calculator, you should get 1.209. So whatever it is that has the base, that's what, or the base of the exponent, that's what you want the base of your log to be, so it'll cancel out. So that's why here we made our base e. So instead of making it log base e, it was just ln, because those are the same thing. Next page. Let's look at 38. So here we're converting. It gives it to us in radians, so we're going to convert to degrees. To convert to degrees, we multiply by 180 over pi. So pi's cancel. You could probably just put this in your calculator to simplify. But 5 goes into 180 36 times. So 36 times 34, which would be 1,224 degrees. All right, for 40, we're finding one positive and one negative coterminal angle. Coterminal angles, you can add or subtract 2 pi if it's in radians, or add or subtract 360 if it's in degrees. So you can do either one, depending if it starts in degrees, you can add or subtract 360. If it starts in radians, add or subtract 2 pi. So here it's given to us in radians. So let's add 2 pi to find a positive coterminal angle. So here we're just adding fractions. We can make it 2 pi over 1, but when we add fractions, what do we need? Same denominator, so I'm going to make this 6 pi over 2. So it gives us 20 pi over 3. So that would be our positive coterminal angle. To find a negative one, we're going to subtract 2 pi. So we have 14 pi over 3 minus 2 pi. Again, we need a common denominator, so I can make it 6 pi over 3. 14 minus 6 would be 8 pi over 3. That's not negative yet, so let's subtract another 6 pi over 3. So that would be 2 pi over 3. Again, not negative yet. These would actually both work for positive coterminal angles. But let's subtract another 6 pi over 3. So we get negative 4 pi over 3. So this would be our negative coterminal angle. All right, for 42, it says given cotangent of theta is 2 over 5, and theta lies in quadrant 3, we have to find sine. So we want to use SOHCAHTOA here. Cotangent is the reciprocal of tangent, and since tangent's opposite over adjacent, cotangent would be adjacent over opposite. So we found adjacent and opposite. Now we want to find the hypotenuse. Anybody remember how we find the hypotenuse? So we use, yes, so Pythagorean theorem. So 2 squared plus 5 squared is equal to, we can say, our hypotenuse squared. So 4 plus 25 is equal to our hypotenuse squared. 29 is our hypotenuse squared. We take the square root. Simplify a radical if you can. Remember, your answer choices are going to be multiple choice. So if you don't see square root 29, it may be just the simplified version of what your answer is. We can't simplify square root 29, so we just leave it as square root 29. Now when we find sine, sine is what over what? Opposite over hypotenuse. So sine of theta is equal to 5 over square root 29. Can we leave our square root in the denominator? No, we have to rationalize. Again, this wouldn't be an answer choice, it would be the rationalized version. So multiply the top and the bottom by square root 29. So we get 5 square root 29 over 29. Now the last step is it tells us it falls in quadrant 3. 1, 2, 3, 4. So all students take calculus. What's positive in quadrant 3? Tangent. So sine would have to be not positive. So it'd be negative. So just tangent and its reciprocal cotangent are going to be the positive ones. So that means everything else will be negative. So it has to be negative 5 square root 29 over 29. All right, 43, we want to find the reference angle. Reference angles are always acute and positive. So we always want to start with something in between 0 and 360 before we find our reference angle, and then it just depends on which quadrant we're in to find what our reference angle would be. So let's add 360 to it. So 360 plus negative 137. Yeah. We get 223. To find our reference angles, if we're in the first quadrant, the reference angle is going to be whatever theta is. Second quadrant, we do 180 minus theta. Third quadrant, theta minus 180. And fourth quadrant, 360 minus theta. Probably not this. But if you use the wrong formula, your answer is not going to be acute and positive. So just know your reference angle is going to be like the smaller version of the angle that it gives you. So it has to be acute and positive. So if you use the wrong formula, you're either not going to be acute or not going to be positive. So try a different formula. So here we're in the third quadrant. So we're going to do 223 minus 180. 43. So our reference angle is 43 degrees. So the first quadrant is 0 to 90. Second quadrant's 90 to 180. Third quadrant's 180 to 270. Fourth quadrant is 270 to 360. So 223 is in between 180 and 270. It would just be like if when you added 360, it ended up being like 45 degrees. That would be your reference angle because it's already acute and positive. So like if you're in between 0 and 90, whatever angle you have is going to be your reference angle. You always want to start in between 0 and 360 so you can use the formulas. So you can add 360 as many times to start in between 0 to 360. And then once you have something in between 0 and 360, then you can plug it into a formula. Because you can't take negative 137 and plug it into one of your formulas because it'll throw it off. All right, let's look at 46. So I think the last things that we have to talk about are the triangles. So like law of sines, law of cosines, and then Heron's formula also, which these formulas will be given. Law of sines, we set up a proportion. So we have sine of the angle over the side A is equal to sine of the angle over the side. And then same thing with C. Sine of C is equal to the side C. So here, let's start with the pair that we're given. So we're going to say sine of the angle, so 52 over 27 is equal to sine of C over 29. So we're looking for angle C. So to solve, we're going to cross multiply, or just multiply both sides by 29. We can do that. So sine of 52 times 29 divided by 27. And you should get 0.84638 is equal to sine of C. Now we want to find the angle, so we take the inverse sine. So then we want to take the inverse sine of that number to find what angle C is. So angle C is equal to 57.8. So angle C is equal to 57.8. Again, this is going to be a multiple choice question. So once you find one of the sides, you could use process of elimination, or one of the angles, use process of elimination to pick your answer choice. There may only be one answer choice that has 57.8, so you don't have to keep working. If there's more than one, let's keep working to find the next angle. So if we're given two angles, 52 and 57.8, how could we find the third angle, angle B? What would we do?
Subtract from 180.
Awesome. We would add 57.8 plus 52 and subtract that number from 180. So we get 70.2 degrees. So angle B would be 70.2. Yeah. And then now we're just missing side B. So we'd set up a proportion to find side B. So sine of 70.2 over B is equal to sine of A over A, which we know that's sine of 52 over 27.
So what do we do to get angle B? You subtract them and add it 360.
So it's a triangle. So all three sides of a triangle add up to 180. So we would do 180 minus the two sides that we have. So here when we solve, we can multiply both sides by B. Or actually, we can cross multiply here to make it a little bit easier. So 27 times sine of 70.2 is equal to B times sine of 52. And then we'd have to divide sine of 52. So we're going to put this into our calculator. So 27 times sine of 70.2 divided by sine of 52. And you should get 32.2. If you put this all in your calculator in one shot, just make sure you close the parentheses. It'll usually, most calculators will open the parentheses here. Make sure you close it before you divide. I usually will just do the top, put equals, and then figure out what the bottom is. Heron's formula, this will be given to you, but you have to find S. So S is equal to A plus B plus C over 2. So you add up all your sides and divide by 2. And then the area, which is what you're trying to find, is S times, I think it's A minus, or S minus A, S minus B, and S minus C. Again, the formula will be given to you. This, just plug it into the formula. Your sides are A, B, and C, so plug those in. Law of cosines, again, formula will be given to you. Just take what you're given, plug it in, and solve for what's left in your formula. You can do law of cosines once and then use law of sines from there. For 52, to solve each equation on the interval, these you use the unit circle. So you always want to get your trig function all by itself. So since we're multiplying by square root 3, we would divide by square root 3. So tangent of x is equal to 1 over square root 3. As a reminder, sine, you look at y, cosine, you look at x, and tangent is y over x. So here we're looking at y over x on the unit circle. We're looking for 1 over square root 3, which would be this one. So that would be pi over 6. So x is equal to pi over 6. So here, once you get your trig function all by itself, go to the unit circle. Remember, sine is y, cosine is x, and tangent is y over x. So we go to 300 degrees, which would be here. Is cosine x, y, which one? X or y? Cosine's x. So our x value here would be 1/2. So cosine of 300 is 1/2. Yeah. And then the last one is our identities. So you're going to be given your identity sheet too. So this one also. So here we're simplifying the identity. You want to make it as small or as condensed as possible. So if you have two fractions, you may need to try to find a common denominator. Here, everything's in terms of tangent and cotangent, so we can try to use our reciprocal identities. So cotangent is 1 over tangent, and tangent's 1 over cotangent. So I'm just going to make everything in terms of tangent and see where that gets me. Cotangent would be 1 over tangent. And cotangent here would be 1 over tangent. What do we do when we have a fraction in a fraction? Keep, change, flip. So keep the top, change to multiplication, we'll flip the bottom, so it's tangent over 1. So this would be tangent squared. Plus here, keep the top, change to multiplication, and flip the bottom, it'd be 1 over tangent. So this would be 1 over tangent squared, which is the same as cotangent squared. And then here we probably just use one of our identities.